Hi, good day everyone. This video is about theorems on central angles, arcs, and chords. Right, so I have a different set of problems for theorems on central angles, arcs, and chords, and then let's try to answer these set of problems one by one. Right, so number one is what are the different theorems on central angles, arcs, and chords? Actually, we have three. Okay, number one is for the theorem on central angles and their corresponding arcs. Right, so for example, we have this given figure. Let's say we have this first angle, right? So that is angle BAC. Okay, if angle BAC is congruent to another central angle, let's say we have this angle EAD, okay, or this part. So BAC is congruent to angle EAD. So automatically, according to our figure, their corresponding arcs are also congruent. Okay, that means arc BC, alright, so this part, arc BC, is congruent to arc ED. Alright, so that is our first theorem. So that means we have this arc BC for BAC, right, that is congruent to arc ED, okay, of angle EAD. Right, so that is our first theorem. Number two is theorems on central angles and chords. Again, same concept. If there's central angles, for example, BAC, right, if that is congruent to another central angle, which is EAD, automatically their chords are congruent. So that is, for example, we have this chord, we have this line segment BC, right? So line segment BC, that is automatically congruent to line segment ED, okay, of angle EAD. Okay, that is our second concept. And then last is the theorems on arcs and chords. Okay, same procedure. If two chords are congruent, okay, then the corresponding chords are congruent, or their corresponding arcs are congruent, and vice versa. Right? So for example, we have this line segment BC, right? If this line segment BC is congruent to line segment ED, then their corresponding arcs are also congruent. Right? So again, if we have this different set of central angles, arcs, or chords inside a circle, if we have this angle which is congruent, automatically the rest will follow. Right? So let's try to apply or answer some problem. Right? Let's apply this set of theorems. Okay, number one is, for example, we have this given figure. By the way, let's answer this figure with use of the concept of central angle. Okay, let's try to explore the concept. Again, we have this BAC, which is 65 degrees in measurement, and then we have this EAD as 30 degrees. Right, so let's try to solve for the value. Okay, number one is, let's say we have this arc BC. So what will be the possible value of arc BC? So where is arc BC? So we have this part. Right, so that is arc BC. Again, so to answer this, let's apply the concept of central angle. So according to the concept of central angle, central angles are actually equals, okay, to their corresponding intercepted arc. So for angle BAC, we have this endpoint at point B and at point C. Automatically, this arc, okay, this part is equal to its corresponding central angle. That means if this BAC is 65, automatically arc BC is equals to 65 degrees. Okay? Same with arc ED. Okay? So since we have this arc ED, okay, for this arc, or this minor arc ED, since the corresponding central angle is 30 degrees, automatically the measurement of this arc is also 30 degrees. Right, so that is the measurement. Next, additional question. For example, you're asked to solve for the value of angle, let's say CAD. Okay, so angle CAD. So first question is, where is CAD? So let's remove this one. Alright, so according to our figure, CAD is actually located here. So from letter C, okay, A and D. So another example of central angle, okay, for this figure. Again, to answer this given problem, CAD, right? So let's apply the concept of, actually we need to apply the concept of diameter. Okay, so according to our given figure, actually we have this diameter for line segment BE, that is line segment BE, right? So that is a line that intersects the center of our circle. So automatically, if that is a diameter, it divides our circle into two equal parts. Okay, that means we have this 180 degrees for this part and another 180 degrees for the entire part of that circle. Okay, since we have this value, okay, we have this 65 degrees for arc BC, right? So we have this 65 degrees and we have this 30 degrees. Therefore, we need to add the remaining part, okay, this remaining part or arc, okay, to have 180 degrees, okay? Therefore, the value for CAD, so it will give us 65 degrees plus 30 degrees, okay, plus x, and that is equals to 180, okay? So if we sum up all of those values, the value is 180. Therefore, so let's simplify this one. So 65 plus 30, that is equals to 95. Okay, that is 95 degrees plus x, or this part, okay, which is actually equal to our missing part, that is CAD. So plus x, and that is equals to 180. Right, so let's solve for the value of x. Therefore, that is x is equals to 180 minus 95, and then 180 minus 95, the answer is 85. Right, so that is 85 degrees. Therefore, the value of angle CAD, so according to our solution, that is equals to 85 degrees. Okay, so I will remove this one. So I will write 85 degrees. Therefore, if this angle CAD is 85 degrees, automatically its corresponding arc CD, okay, arc CD is also equals to 85 degrees. So that is actually the concept of central angles for this question number 1. Okay, next, let's try to answer this problem number 2. Right, so for our problem number 2, we have this given circle. This time, let's try to apply the concept or the different theorems on central angles, arcs, and chord. Right, so let's find the value of x. Okay, so according to this figure, we have this tick marks for line segment DE. Okay, that is a chord. So we have this DE, and that is congruent or equal to BC. Okay, so if that is our given measurement, automatically the rest will follow. The corresponding arcs and chords or central angles are congruent. Therefore, the measurement of angle DAE is actually equals or congruent to angle BAC. Okay, so according to our figure, DAE is equals to x, or by the way, that is 80, and the value of BAC, so according to our figure, that is equals to x. Okay, that means just equate those values. Therefore, the value of x is simply equals to 80 degrees. Okay, that is our answer. Right, so obviously, if we have this 80 degrees for this given angle, automatically this x is equals to 80 degrees. Okay, so that is our question number 2. Next, for question number 3, so let's find the value of x. Okay, so for this given figure, we have this measurement, we have this equal central angle. Okay, so according to our mark, we have this angle DAE, so that is congruent or equal to angle BAC. Okay, therefore, the value or the measurement of this chord, okay, chord DE, is actually congruent, okay, according to our theorem, that is congruent to this line segment BC. Okay, again, for this figure, if our central angles are congruent, then their corresponding chords or arcs are congruent. So for this given problem, we have this DE as the chord and another chord. So they contain the same measurement, right? So obviously we have this measurement. We have 85 for their arcs. Then let's solve for the value of x. Okay, so according to our figure, DE is equals to x plus 1. Okay, that is x plus 1. And then BC is equals to, right, so we have the 7. So let's equate those values and then let's solve for x. Right, so it will give us x plus 1 is equal to 7. So let's subtract 1 both sides or transpose the value of 1. It's up to you. Right, so our task is to isolate the value of x. So by applying APE, let's subtract 1 both sides. Therefore, the value of x is equals to 7 minus 1. That is equals to 6. So that is our answer. Okay, x is equals to 6. Right, so next, let's try to answer question for this figure, okay, for this given figure, we have this chord. Okay, we have this chord BC. So according to our figure, we have this line segment BC that is congruent to line segment DE. Okay, so if we have this given set of values according to our theorem, their corresponding central angles are also congruent. So that means angle BAC is also congruent to angle DAE. Okay, so according to our figure, BAC is equals to 2x plus 5. Alright, so let's find the value of x. So we have 2x plus 5, and then the value for DAE, that is equals to 75 degrees. We have 75 degrees. So let's solve for x, okay? So let's equate this set of values, and then let's isolate the value of x. So I think we need to subtract 5 both sides, right? So to isolate the value of x, therefore, we have 2x equals to 75 minus 5. Cancel this one. So 75 minus 5 is 70. Divide both sides by 2. Therefore, x is equals to 35 degrees. So that is our answer. Okay? Again, if you're asked to solve for the value of, let's say, value of BAC, since they contain the same measurement, automatically BAC is equals to 75. Right? So if you want to double check your answer, again, let's double check. According to our figure, we have this x as 35 degrees, and then we have this angle BAC as 2x plus 5. Okay, so let's double check. So let's do some checking for this given figure. So we have this 2 times, let's plug the value of x, we have 35 plus 5. Okay, 2 times 35, that is 70, plus 5, that is equal to 75 degrees. Okay, so automatically they contain the same measurement. Okay, next, so let's try to answer this given figure. Alright, so for this given figure, we have this congruent chords. Okay, so again, we have this chord, we have this line segment BC that is congruent to DE. Again, the rest will follow. The central angles are congruent and their chords are congruent. So for this given figure, we have this arc. Okay, we have this arc BC and a value for arc DE. So let's equate their given measurement and let's solve for the value of x. Okay, so for BC, according to our figure, we have this value as 7 or x plus 7. Okay, that is x plus 7. And then for DE, we have 3x plus 1. So let's equate this one to 3x plus 1. And let's solve for the value of x. Okay, so I think we need to subtract x both sides. And then let's subtract 1 both sides. Right, so therefore the value is, we have 3x minus x, that is 2x. Cancel this one. And then cancel x, and we have 7 minus 1, that is equal to 6. Okay, and then divide both sides by 2. Therefore, the value of x is simply equals to 3. So that is the answer. Right? Therefore, for example, you are asked to solve for the value of the given arc. So just substitute the values of x. Okay? Since we have this BC, so we have this arc BC. So according to our figure, the measurement of BC is x plus 7. Right? Since the value of our x is 3, therefore that is 3 plus 7, and that is equals to 10 degrees. Right? So next, for DE, okay, so according to our figure, the value of DE is 3x plus 1. Since the value of Rx is 3, that is 3 times 3 plus 1. 3 times 3 is 9 plus 1. That is also equals to 10 degrees. Again, they contain the same measurement. Okay? So that is for question number 4. I think number 4. Next, let's answer this one. Alright, so according to this figure, okay, same procedure. Let's apply the theorems for central angles, arcs, and chords. According to this figure, we have this congruent chord. Okay, we have this chord BC, line segment BC. According to our figure, that is congruent to CD. Okay, they contain the same measurement. Since the value of our central angle, we have this central angle as angle BAC. Okay, that is our first central angle. And the second one is angle CAD. So automatically, by the way, they contain the same measurement. So according to our figure, BAC is equals to 5x plus 1, or 5x minus 10, by the way, 5x minus 10. And for CAD, right, so we have this symbol, we have this square symbol, okay, that is actually 490 degrees, okay? That means the value of this part, okay, the value of this part is 90 degrees. So let's equate this 5x minus 10 to 90 degrees. And then let's solve for the value of x, okay? So let's isolate the value of x. Let's add 10 both sides and then solve for x, okay? Therefore, it will give us 5x, cancel out. We have 90 plus 10, that is equals to 100. Divide both sides by 5. Therefore, x is equals to 100 divided by 5, that is 20. So that is the value of x. Okay, so if you want to double check your answer, right, so just plug in the value of x to our expression. So for checking, again, the value for expression, we have 5x plus minus 10. Let's plug this value. We have 20, so it will give us 5 times 20 minus 10. So 5 times 20, that is 100. Okay? Minus 10, that is equals to 90 degrees. And that is actually equal to angle CAD. Therefore, our answer is correct. Okay? X as 20 is correct. Okay, next. So for this given figure, I think this is our last figure for this given discussion. Right, so for this given figure, let's try to solve for the value of x, okay? So we have this congruent chords. Automatically, their arcs are congruent. But this time, we have this value of x alone, okay? Let's use the value, okay, or the given values of our remaining minor arcs, okay? So for this given problem, we have this AB, okay, that is congruent to CD. Since they contain the same measurement, automatically their arcs are congruent. That means arc AB is congruent to arc CD. Alright, so according to our figure, we don't have any value for AB. We have this x, okay? Then let's try to use the concept of circle. Since the total measurement of circle is 360 degrees, okay? The entire measurement of the arcs, or by the way, the entire circle is 360. So we have this given value for BC, right? So again, if that is 360, then AB, arc AB plus arc BC plus arc CD plus arc AD, their value is equals to 360 degrees. Okay? The total measurement is 360. Now, AB is equals to CD, right? The value of AB is equal to CD. And then the value of BC, so we have this 80 degrees. Okay, we have 80. And then for AD, we have this 60 degrees. Right, so if we have this given set of value, let's add this one. And then let's subtract their sum to 360 and then divide the answer by 2. Okay, so let's add this. So we have 80 plus 60. The answer is, alright, so that is 140 degrees. Right, so since we have this 140, let's subtract this 140 to the entire measurement of a circle, that is 360. Therefore, that is 360 minus 140 degrees. Right, so 360 minus 140, that is equals to, I think that is 220 degrees. Okay, so we have this 220 degrees. That is for the value of AB and CD. Okay, since they contain the same measurement, okay, according to our theorem, they contain, or they're congruent. Therefore, we need to divide this 220 by 2. Okay, for the individual values of AB and CD. Therefore, 220 divided by 2, that is 110 degrees. Okay, therefore, according to our figure, the value of x is 110 degrees. So this part is 110 and this is 110 degrees. Right, so if you want to double check your answer for checking, okay, so for our checking, just sum of, okay, the entire measurement of this set of minor arcs. Therefore, that is actually equals to 360. Okay, so it must be equal to 360. So let's try to double check. Okay, so again, we have 110 degrees plus 110 degrees plus 60 degrees for AD and plus 80 degrees for arc BC. Right? So 110 plus 110, that is 220. So this is 220 plus 60, that is 280, plus 80, that is equals to 360 degrees. Therefore, our answer is correct. So the measurement of arc AB is 110 and DC, that is 110 degrees. Right, so thank you so much everyone, and God bless guys.